Hi, hello everybody. So this is the topic from our syllabus 8.1 dealing with uh, completing the square. Now we call it completing the square in the workbook, but this is actually solving quadratic equations, and completing the square is one of the techniques that we're going to see. And just to make sure that we clarify that this is a process of solving quadratic equations, I have here an introduction for us that will go over what a quadratic equation is. This is the format, where the format is ax squared plus bx plus c equals to 0, where the coefficients a, b, and c are just numbers. And if it is a quadratic equation, the coefficient to the x squared cannot be 0, because if it is, then we just have bx times c equals 0, and that's not a quadratic equation. So here is a quadratic equation, and the three techniques that we have to solve it are mentioned here. The first one, we saw it in the beginning of the semester, it's by factoring, section or topic 5.7. The technique we're going to see now, called completing the square, which uses the square root property that I'm going to go over now, which is topic 8.1, and the technique of using the quadratic formula, which is topic 8.2, which we're going to see in a separate video. So these are the three techniques. The first one we saw, and let's go over completing the square technique. So before going over the technique of completing the square, it is important to mention that this technique is performed by using the process of applying the square root property. Now, the square root property is a very simple property that solves a basic equation, as you see right here. X squared equals a number, for example, whatever the number is. And I'll give you an example shortly. So if the equation is in this format, the technique of completing the square, which relies on the square root property, says take the square of both sides of the equation. And when you do, the square root of x squared is x, and the square root of b is the square root of b, but with the plus or minus in front. And the reason for that is, for the square root, there is going to be two possible solutions to the original equation x squared equals 2b. And here is an example. So imagine that we have this, x squared equals 16. Okay, yes, we know how to solve it by factoring. We know how to solve it algebraically, but we can imagine that even without solving mathematically or algebraically, imagine the possible values that you can square that can give you 16. Well, certainly 4 squared is 16, so that checks. But also negative 4 squared is 16. Okay, and if we wanted to solve this algebraically, we subtract 16 from both sides. We get this equation. We know how to factor this. This is difference of squares. X minus 4, x plus 4. And then applying the zero product rule, either this factor is 0 or this is 0. So we set both to 0, and we solve them for x. From the first one, after I subtract 4 from both sides, I get this. And when on the second equation, when I add 4 to both sides, I get. So here are the two solutions to the equation x squared equals 16. So this is a formal procedure for this particular problem. In general, this is the square root property. Skipping all of this. If you have an equation that looks like this, x squared equals a number, all we have to do is take the square root of both sides. The square root of x squared is x. The square root of 16 is 4. But you must put in the plus or minus. And you saw the plus or minus from the full solution process. This is the square root process. So we are going to do a couple problems to demonstrate how the square root process, the square root property works. And once we are comfortable with this procedure, we are going to use it to solve the other problems dealing with completing the square technique. So let's take a look at the square root property is basically what you see over here. Let's use it to solve these three problems using this property. And notice that to use the property, I have to have something in parentheses with the square already. Okay. And all I need to do is first make sure that the parentheses with the square is isolated on the left side. The right side, you must have a number. And once we have that format, we'll apply the square root property, which is take the square root of both sides. After you do, you will have a plus and minus on the right. So let's take a look. I'm going to do the first problem, x minus 3 squared equals 15. So these will be all under solve. X minus 3 squared equals 15. Let's just make sure that this is the problem. X minus 3 squared equals 15. Yes, that's it. So step one is make sure that the parentheses with the square is isolated on the left. It's already isolated. I'm ready to go. So I can apply the square root property immediately, which is just take the square root of the left, take the square root of the right. On the left side, the square will cancel with the radical. I am left with x minus 3. On the right side, I will always have a plus or minus. So immediately you put the plus or minus here. If you can simplify square root of 15, you simplify. In this case, you cannot. So it just stays as square root of 15 because it cannot be simplified further. My final step now is to solve for x. And this is a simple equation. All I need to do is add 3 to both sides. When I do, these two cancel. I end up with x equals 3 plus or minus radical 15. And that's my final answer. Yes, that's it. That is as simple as that. So applying the square root property is very straightforward, provided that you start with the factor squared isolated on the left. Okay. Let's take a look at the second problem, which is now x plus 6 squared minus 20 equals 0. So x plus 6, so maybe let's use solve again. X plus 6 squared minus 20 equals 0. And let's confirm that this is the problem. Yes. Okay. So first step, I need to isolate this factor. And I will do that by making sure that the 20 is on the other side. These will cancel. I am left with x plus 6 squared equals 20. Now I am in a similar situation than before. In the previous case, the equation was already isolated on the left with the number on the right, just like I am right now. At this point, I am ready to go and take the square root of both sides. This is what we call apply the square root property. When I do, this square will cancel with the radical. I am left with x plus 6 equals. On the right side, I immediately write plus or minus because that's the key element of the square root property. And now I have square root of 20. And square root of 20 is different from square root of 15. I can simplify square root of 20. And the square root of 20 has to be broken as radical 4, radical 5, because this becomes 2. There's nothing I can do with radical 5, so it stays as 2 radical 5. So you would write this over here. And now, as before, my last step is to solve for x, meaning leaving x isolated on the left. I have to subtract 6 from both sides. They cancel here. And notice this minus 6 does not get subtracted from here because these are not like terms. You will just write minus 6 plus or minus 2 radical 5. These two are not like terms, right? We've covered like terms. They are not like terms because the radical 5 is multiplying the 2. So this is my final answer, minus 6 plus or minus 2 radical 5. So the key element here is this number needed to go to the other side before I can apply the square root property. Okay, last problem. X plus 1 squared equals negative 8. So this is an important problem. Again, solve x plus 1 squared plus 8 equals negative 8, but it's the same thing. So we'll just erase this here. Equals negative 8. Okay. And the factor with the x squared is already isolated on the left. So I can go and immediately take the square root of both sides by applying the square root property. Again, the square cancels with the radical. I am left with x plus 1. Notice I don't need to put the parentheses here. So I just write x plus 1 equals. But on the right side, you immediately write plus or minus. The problem now is we have this minus over here. So I'm going to do it on the side. And I need to know how to simplify this. And we covered this in section 7.7, topic 7.7, that this needs to be rewritten as 8 times minus 1. And from complex numbers, I know that the minus 1 gets rewritten as I squared. Now, all I have to do is see how I need to break 8 so that I can simplify this radical. And we know how to simplify 8. I am going to write it as square root of 4 times square root of 2 times square root of I squared. This is 2. I cannot simplify that. And square root of I squared is identical to square root of x squared, which is just, in this case, I. Always rewrite the radical last, so your solution here would be 2i radical 2. So this value you would write right here. So the square root of negative 8, which is an imaginary number, gets rewritten as 2i radical 2 through the process of simplification as you see here. My final step is subtract 1 from both sides. These will cancel. This minus 1 does not get added or subtracted here. It just stays in front. Plus or minus 2i square root of 2. Okay? So this is how you will solve these quadratic equations using the square root property. And this is the basis, as we'll see shortly, this is the basis for applying this technique on completing the square approach, which we'll see in this next video.